In the previous video, we left off with how to use and read the table A in the back of the text. Basically, this table is using the fact that the normal curve is symmetrical, with the mean being the center point, and the entire area under the curve being the whole number 1.0, which represents 100% of the population. And due to the fact that it's symmetrical, we can reduce the amount of tables we need if we can understand how to use this table and the area under the curve to our advantage. We left off with talking about if you had a z-score of 0.015 and you wanted to find out the area under the curve, or the proportion of the population that is between your value and the mean, then you would use this column B table of the table to see that 0.15 corresponds with the area of 0.0596, which means 5.96% of the population would fall between a z-score of 0.15 and the mean. The third column here represents the area under the curve from that z-score to the tail. So this 0.15 is the same location just to the right of the mean, but instead of this column, which gives you the area from that point to the mean, this column gives you the area from that point to the tail. And if you notice, these two values always add up to 0.5, because right now all it is focusing on 1/2 of the curve. You know that 0.5 or 50% of the population is between the mean and the tail. Now let's walk through how they use this table to find the area under the curve for examples. In this one example, they were looking for to find the proportion of the population that was between 245 and 255. This was for a set of data that had a mean of 270 and a standard deviation of 15. So what we did here was we have a normal curve with the mean here at the middle at 270, and the values of 245 and 255, which were given in the problem right here, are marked as so. And what we're trying to do is find out what is the proportion of the population that lies in this range right here. So we first need to find the z-score for each of these points. 255 is exactly 15 points below the mean, or 1 standard deviation below the mean. So this z-score is negative 1.00. That's this curve right here, negative 1.00. 245 is a little further out. It's not as much as 2 standard deviations, but it's close. And if you subtract the two, 245 minus 270, get a value, and then divide by the standard deviation of 15, we get negative 1.67. That's the z-score for 245. So now we're going to use this table to find the area between these two regions. We first find the area from negative 1.0 to the tail. Now, this left side of the chart, or the normal curve, is symmetrical with the right side. Our table in our text has all positive z-scores, but we have a negative z-score here. We're just going to use the same information of a z-score of 1.00 and then apply it for a negative 1.00. So if we take a look at the z-scores, and I follow this column all the way down to 1.00, we see that there's two values here. Now remember, this first value is the area from that point to the mean. We want the area from that point to the tail. So 0.1587 is the proportion of the population that is between the z-score of 1 and the tail. That corresponds to right here. And that's how they got that information of 0.1587. Then we're going to use the table to find for negative 1.67. That provides an area under the curve of 0.0475. This is where you have to use a little math and understand that if I know that the area from this point to the tail is 0.1587, and from this point to the tail is 0.0475, then the difference, or this little section here, is the difference between those areas. So I subtract those values to get 0.1112. That is the proportion of the population that falls within this range of 245 to 255, or roughly 11%. On the next page is an example where they walk you through how to find the area under the curve to the tails together. Again, this problem, they're looking for the proportion of the population that is beyond 30 points from the mean. This was an example where they gave you a mean of 105 with a standard deviation of 15. I think they were IQ scores. So we set up a table here, or the normal distribution, with 105 in the center point of the mean. And again, we're looking for 30 points from the mean, 30 above and 30 below. And we're looking for the proportion of the population that falls beyond those 2 points. So beyond those 2 points, I need the area from this point to the tail. So I need to find the z-score for each of these. They are both equally distant away. And they both end up being exactly 2.00 z-score, one in the positive and one in the negative. We're going to use the table in the back of the book, follow the table of the z-scores all the way down to 2.00, and find the area from that point to the tail. Ends up being 0.0228. Now that's the area under this little curve in the tail from 2.00 to the positive tail. The area from negative 2.00 to the negative tail is identical due to the fact that the curve is symmetrical. So to find the total proportion or area under the curve beyond the value of 30 points from the mean is 0.0456. I hope that helps walking you through those problems. Feel free to email me if you have any questions. And again, work together as well on the Slack discussion space. Thank you.